Hello friends, let's talk about cap theorem today. Let me go through some of the properties in cap theorem. There are three properties that the cap theorem talks about. Cap theorem as it relates to distributed systems. The first property is consistency. What is consistency? In a distributed system between clients and servers, that is the request response model, all read requests made by clients receive most recent writes by the server. What is availability? All reads receive data, it may not be the most recent, and hence the system is available but not consistent. What is partition tolerance? All reads continue to get served despite of network partitioning. These are the three properties that cap theorem talks about. That's what cap is an acronym for consistency, availability, and partition tolerance. So what is cap theorem? The cap theorem states that all three of the properties, that is consistency, availability, and partition tolerance, cannot be achieved simultaneously in distributed systems. Only two of the three properties can be achieved. That is, a system can be a CA system, an AP system, and a CP system. One thing to note here is that in distributed systems, network partitioning is always given. At any point of time, you should always build systems such that the system expects partitioning. In that case, the CA system doesn't make sense. A CA tolerant system, but which is not tolerant to network partitioning doesn't make sense because partitioning is always given. And hence, the two choices for any system are either CP or AP. So let me explain this visually. Okay, so let's assume a single server system that serves the clients. So in this case, this system is consistent, right? Because whatever requests that the client makes, whatever writes that the client makes will go to the single server, will get served by the single server, and then all the reads by various clients or even that particular client will get served by the exactly same server. Hence, it will always return the consistent data. So the system is consistent and the single server is also available as long as there is no failure. However, this particular single instance of the server that introduces single point of failure. So if a network gets either partitioned, then some of the clients will not be able to reach that single server because they're partitioned, or the single instance of the server goes down. So then all the clients in the entire globe, they will not be able to get served. And so this single server introduces a single point of failure. So the next question is, how do you remove this single point of failure? You have two instances of servers that are replicated, and hence any number of clients, they can send their requests to either of the two servers. And so the problem is alleviated from single point. Now you have two instances of server. So in this way, as you can imagine, that you can have any number of instances of servers, you can have nth degree of replication depending on various factors, how many clients you have, or how much of the geo location of the clients you have, what is the reliability of the network, etc. And so that removes the single point of failure, but that introduces another issue, that is the replication of the data. The more replicated servers you have, you need to make sure that the data gets replicated to all of the servers in order to be consistent. So the less time it takes for the data to travel from server 1 to server 2, the sooner both the servers can start serving with the latest data, making the system more consistent. So as you can see that there is a trade-off between consistency and availability. If the data is not consistent, then the system can still be available. It can serve with the outdated or a little bit older data, a previous version of the data, just that the data will not be latest, but the system is still available to serve the requests. So in that case, the system will still be available. But if the latency of the data replication is low, then the system will be consistent. And hence you have this trade-off. In the presence of network partitioning, the system can either be consistent or available. but not both. So, so that is what cap theorem is all about. Please comment. Thank you for your time. Please comment on this video, like this video, share this video, and thank you for listening.